Okay, CBE number 5. So, determine the real number solution to the equation below. Enter each solution separated by a comma. If there are no solutions, then type NS in the answer box. So, here we're going to need a common denominator. So, this one factors into x times x squared plus x minus 2. Does that factor any further? It does, right? So x times x minus 1 and x minus 2. Okay? You guys get that? Now I need a common denominator everywhere. So this one needs an x squared plus x minus 2. What? Oh, sorry. Sorry. There we go. Thank you. Does everybody follow so far? The left side needs an x minus 1 and an x plus 2. What does the middle fraction need? Nothing. It has all of it. And what does the fraction on the right need? An x and an x plus 2, which is x squared plus 2x. And I also need to put all of those in the denominator. But once I do, what's the next step? Just get rid of them, but we have to remember what? X cannot be 1, -2, or 0. Does everybody understand why? Carly doesn't have a mask on. Does everybody understand why x cannot be those numbers? We're good? Okay. So we'll just remember that, and at the end we'll double check our answers and see if we need to throw any of them away. So the numerators now become 7x squared plus 7x minus 14 plus 8 is equal to 6x squared plus 12x. What should I do now? So when I see x squared, what do I think? What should you think whenever your equation has an x squared? I could have two answers, and I need to make it a quadratic and factor or somehow solve it. So, excuse me. Subtract that over, and I get x squared. Subtract this over, and I get negative 5x. And then negative 14 and 8 makes negative 6. That factor, x minus 6 and x plus 1. So my roots are 6 and negative 1. Are either of those not allowed? No. So what if this doesn't factor? What do you do? You would do the quadratic formula, or you could complete the square. Okay. Was that number 3? That was number 10? Oh, okay. Don't know how that happened. Let's go back to number 1. All right. Let me check. Yes. So the solution set is negative 1, 6. Yeah. Sometimes on some of the other tests, didn't it make you put them in numerical order? Yeah. So negative 1, 6. Okay. For this one, I want to use elimination. You could use substitution. So I will times this by negative 2. And that gives me 8x minus 2y equals 2. And then I can add vertically, and the y's eliminate. 6x equals, do I have a sign wrong? 8 minus 2 is 6x. Nope. So negative 2. So x is 1/3. And then negative 1/3. Thank you. And then I need to plug that back in. So let's put, neither one of them are really going to be very good. Yeah. So we're going to put negative 1/3 in here. Negative 4 times negative 1/3 plus y equals negative 1. So this is 4/3. So I need to subtract 4/3. And negative 1 is 3/3. So negative 3 minus 4 is negative 7/3. Let's see if I did that correctly. Oh, does it have a fraction thing in there? Okay, so negative 1/3 and negative 7/3. Uh-oh, what'd I do wrong? Okay. Okay. Use any technique and determine the end of the solution as an ordered pair. So, yeah, it says ordered pair, so I should have. There we go. Sorry. It's an ordered pair, so the. Weird. Yeah, that one, the fraction worked there. So why didn't I put parentheses on the last one? No. It was not an ordered pair. They were both x's. So the last one was a set of solutions to a quadratic equation. They're both x's. This one is an x and a y, which is why we need the parentheses. So, okay. All right. Number 2. Okay, so they have done all the hard work for you. So they've taken this equation and they've turned it into what we call an augmented matrix, which, anyway, you can stick them in a calculator and solve it, but they don't allow you to use graphing calculators. So they have done what is called reduced row echelon form. Don't worry about it. And they get this answer. Okay? Now, notice this right here is the pattern we call an identity matrix. It's zeros everywhere except the diagonal going down from the top left is all ones. Okay? And this is our x column, this is our y column, this is our z column, and this is our answer column. So this equation, this matrix is telling us that x, 1x, is equal to 0. 1y is equal to 3. And 1z is equal to 0. Does that make sense? Okay. So the equation, the matrix will almost always look like this. So another example could be 1, 0, 0, 4, 0, 1, 0, negative 6, and 0, 0, 1, 5. In which case, x is 4, y is negative 6, and z is 5. Now, this phrase right here, reduced row echelon form, that means it shows up looking like that. And anytime you have one solution set, then you will end up with 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? Now remember, these are planes. So the first plane might be the floor, the second plane might be the back wall, and the third plane might be the side wall. Do all three of those intersect? Yes, at the point in the corner on the floor. And that point, in this case, is 0, 3, 0. X, Y, and Z. But is it a guarantee that three planes will always intersect at a point? No, they could intersect at a line. So if we had the floor and the back wall, and we drew a new plane that went kind of diagonally this way, then all three planes would intersect at that line created on the back floor. Okay? Or you could have three planes that were identical, in which case they intersect everywhere. Or you could have the floor, the back wall, and the ceiling. Where do they intersect? They don't. So sometimes weird things can happen with planes. Most of the time they don't. So how do we know that something weird is going on? It's really easy. If this pattern exists, then there is one solution coordinate. It's actually like a triordinate, right? X, Y, Z. So here's what it could look like. Could look like 1, 0, 3, 4, 0, 1, 0, 5, 0, 0, 0, 1. So if you see a resulting matrix that looks like this, I do not have that special pattern. If you don't have the pattern, one of two things is happening. Either you have infinite solutions because the planes intersect in more than one point, or you have no solutions. How do you tell which is which? Well, look at the bottom row. What is this trying to tell me? 0x plus 0y plus 0z is equal to 1. What do you think about that statement? It's not true. Is 0 equal to 1? No. So what that means is we have no solution. It doesn't necessarily mean that two planes are parallel, but if we had the floor, the ceiling, and the back wall, that's what it would look like. But we could also have a triangle of planes. We could have a plane here, and a plane here, and a plane here, and none of them are parallel, but they don't intersect anywhere. Right? Two of them intersect, but the three do not intersect. So if the answer is no solution, it will always look like this: 0, 0, 0, 1. There won't be any other numbers in there. Okay, 0, 0, 0, 1 is the only option. All right? What if you see this? What is that telling me? So we look at the bottom row, and that says 0x plus 0y plus 0z equals 0. When does 0 equal 0? Always. So that means the solution set is infinite solutions. Does it mean that two planes are identical? Maybe. Right? But we could draw planes that intersected at that line on the back wall. right? We could have the floor and the back wall, and then we could draw another plane this way, and they intersect at a line. So we're not really going to get in exactly what the structure looks like, but if you have a row at the bottom that is all zeros, that means infinite solutions. Now, there's one little thing you have to be careful about. What's going on there? Well, this is telling me infinite solutions. And this is telling me no solution. So who wins? No solutions wins. So basically, we have two planes that are identical, and then one plane that is parallel to those other two, or something like that. Okay? So if you have infinite solutions, you'll have the bottom row all zeros. If you have no solutions, the bottom row will be 0, 0, 0, 1. If you have both of those, the bottom row is all zeros, and the second row is 0, 0, 0, 1, then no solution wins. Well, it depends. So in this case, you have one solution. If you don't see this, then check the bottom row. But in some weird cases, you might have to check the bottom row and the middle row. So this on the bottom means no solution. This on the bottom means infinite solutions. But if you have this, both infinite and no solution wins every time. Okay? So anyway, that problem should be a piece of cake for you guys. Oh. Oh, sorry. Okay. So they kind of tell you how to write it. If the system is independent, then write the x, y, and z. So if it's independent, that means there's one solution. Okay? Yeah, and it tells you the x and the y and the z. If the system is dependent, oh, this is going to be annoying. I forgot about this, sorry. Define the variable z as the free variable and write the values for x, y, and z in terms of z in the appropriate boxes. Okay, I'll show you how to do that in a second. Okay. If the system, so dependent would mean infinite solutions. Okay. And then inconsistent means no solution. And then you would write the word yes in all caps. Oh, I'm glad you guys reminded me of this. Okay, so the first one is easy. The last one is easy. So this would be if you have this, nope. If you have this, then you write yes in the box, and in the first one, and then NA in the others. You guys get that? So the confusing one is the middle one when you have infinite solutions. When it's okay, so do you guys get the first one? Just plug in the x, the y, and the z, right? So if it's inconsistent, then you write yes there and NA in all these other boxes. Okay? So how do you do one that is dependent? Let me find one. Oh, geez. Can I try another? Will it let you? You guys have one? Okay, awesome. All right. So 1, 0, 1, 0, 0, 1, negative 3, 0, and 0, 0, 0, 0. Okay, so what does this mean? Well, it means x, 1x plus 0y plus 1z is equal to 0. Right? And 0x plus 1y minus 3z equals 0. And then 0x plus 0y plus 0z equals 0. What's happening in this situation structurally? What do we have? What does our answer look like? Infinite solutions. So when would you have infinite solutions? When the three planes intersect either everywhere or they intersect on a line. So floor, back wall, and then if I did a diagonal plane this way, it would all three planes intersect along that line in the back of the room. Okay? So inside this equation is the information telling you where that line is. Now, this is in 3 dimensions, right? So that line is flying through 3 dimensions somehow, and all 3 planes intersect that line everywhere the line exists. Okay? Well, the bottom row doesn't tell us any information other than we have infinite solutions. So I can forget that. And then the top 2 rows can be simplified to x plus z equals 0 and y minus 3z equals 0. You could, but so she's saying they both equal 0. Is that always going to happen? No, but you could move stuff over. But if I set them equal to each other, I get one equation in 3 variables. Okay, and that equation is the equation of the line, and that's totally true. And if you were plugging it into a computer to graph it, that's how you would do it. Okay, but that's not what it's asking us to do. It says, so it says hold z fixed. Where is that? Okay, right there. So it says write the values of x, y, and z in terms of z. So I want to hold z fixed and figure out what x and y are in terms of z. So in this case, we solve for z by subtracting x. So z is equal to negative x. And we subtract y. And I get negative 3z equals negative y. Divide by negative 3. So z equals y over 3. And then z, well, does it have a z? And then z would be what? Z is just z. I'm hoping that's what they do. Plug that in. Tell me what you get. So now the question is, do we have to put NA in all the other boxes? The suspense. But do you guys understand what's going on here? So can you check the answer? Okay, so
but it's not saying these are wrong, so I don't think you have to put any in them.
oh, we solved them backwards. Sorry. Duh. The box says x equals, right?
Yeah, x equals.
So we need to do x in terms of z. So anyway, somebody asked about the equations. Do you see where these equations came from? Okay, so I just simplified. I got rid of the ones and I got rid of the zeros. And I ended up with this and this. Okay, now, sorry, we did it backwards. We need to set every variable in terms of z. So this would be x equals negative z and y equals 3z. Try that. Yeah, sorry, I did it backwards. Got it? Okay, do you want to see another one? Yeah. Okay. Do you want me to do yours, Braylon? Yeah. Okay. So Braylon says 1, 0, negative 9, 5, 0, 1, negative 1, 1, and 0, 0, 0, 0. What if that bottom row is 0, 0, 0, 1? What do I do? Put yes in the bottom box and capital NA in all the other boxes. So what is this telling me? Well, this is telling me I have infinite solutions. So there's some line in 3 space that all 3 planes intersect everywhere. So I want to know where is the location of that line in terms of the x-axis, y-axis, and z-axis. So this equation gives me x minus 9z equals 5. And this equation is y minus z equals 1. So z is equal to z. And then we need to find out what x is in terms of z's and what y is in terms of z's. So I'm just going to move these over. X is 9z plus 5. And y is z plus 1. Give that a shot. The suspense is killing. Yeah, the top equation, 1x plus no y's minus 9z's is equal to 5. Okay. Oh, that's good to know. So you got to put NA in the rest of the boxes. Ugh. Yep, it sounds like it. I don't think it told us that, did it? Okay. Okay. They need a better software check system, don't they? It's really sad when you get the answer right, but you didn't follow their format. Okay. Oh. Okay, there's one. So in this case, I'll just do this really. Oh, that's the same one, isn't it? Anyway, that's the one we just did. Okay. Partial fractions. I love partial fractions. So, x minus 6, x plus 1. How many partial fractions will I have? Just 2. The partial fractions are a over x minus 6 and b over x plus 1. Does it matter the order I put those in? No, because in the end, I'm going to end up with the numbers in the right position. Okay? So what does the a fraction need? X plus 1. What does the b fraction need? X minus 6. So 3x minus 12 is equal to ax plus a plus bx minus 6b. I actually have 2 different sets of information in this equation that do not interact. Okay? This term and this term and this term are completely independent of this term, and this term. Do you guys see that? They do not interact at all. They're completely separate, so I'm going to separate them into two equations. So for my x equation, I have 3x equals ax plus bx. And for my non-x equation, I have negative 12 equals a minus 6b. But I don't need the x's anymore. They're just kind of in the way. So I get rid of the x's to isolate just the a's and b's. So now times the bottom one by negative 1, which is easy, you just change the signs. Then we add vertically. 3 plus 12 is 15. The a's cancel. 7b. And then, oh, really? Did I mess up? Okay, so this is from there. And then on the other side, I took x plus 1 and times it by a, and I got ax plus a. And then on the other side, I took the b and times it by the x minus 6, which gave me bx minus 6b. So then I filtered out the x terms, 3 equals a plus b, and I filtered out the non-x terms, negative 12 plus a minus 6b. Is it really 15/7, or did I mess up? No, that's not. All right. So 15/7 is b. So we plug that in here. And how many sevenths do I need to bump this up to 21? So 6/7. So A is 6/7 and B is 15/7. All right, let's try it. I didn't see a mistake in there anywhere. Okay, so 6/7 times x. That's how I would do it. You could put 6/7 on the top, but it's the same as putting 6/7. I don't know. Let's try it. See what happens. So this is the x minus 6. Where's the delete button? Okay, so x minus 6. How do I finish that? It does it by itself. Okay. And then plus 15 over 7, and then x plus 1. All right. See if I got it. How does? Oh, I factored it wrong. Oh my gosh. Nobody caught my mistake. Sorry. I factored it into x minus 6 and x plus 1. but that doesn't work. It's 2 and 3. Okay, sorry. So x minus 2, so a over x minus 2, b over x minus 3. Do you guys just wonder how I ever passed college? I don't know. Well, if I made it, anybody can make it. All right. So this one is x minus 3. This one is x minus 2. I've never seen the answer on partial fractions be a fraction itself, which is why I was really confused there for a second. Okay. ax minus 3a plus bx minus 2b equals 3x minus 12. You guys get to see two of these now. The wrong one and the right one. Does everybody understand what I've done? Anybody confused? Cameron, you good? Okay. So we filter out these terms. So a plus b equals 3. And then we filter out these terms. So negative 3a minus 2b equals negative 12. All right. I'm going to double the top. 2, 2, and 6. Now the b's cancel. And 2a minus 3a is negative a. 6 minus 12 is negative 6. So a is 6. Yeah, I like that number. And we know that a plus b equals 3. So b would have to be negative 3. Does anybody have this same problem? So the answer is 6 over x minus 2, and then minus 3 over x minus 3. Okay. Oh. This is cruel. They didn't do this in the textbook. Why am I making moaning noises? It's an improper fraction, right? So if I had the fraction 3/4 and I said, well, that's probably a bad idea, 3/12, and I said, what fractions did you add together to create 3/4? That's not too hard to do. We would need a something over 2, we would need a something over 3, and we would need a something over 2 squared, which would be 4. Right? But what if that fraction is top heavy? Well, there is a 1 inside there, right? And the partial fractions will be of the remainder. So how many times does 12 go into 17? 1, remainder 5. But nobody in their right mind is going to list remainder 5. What is that really? It's 5/12. You guys see that? So this is the reason that the fraction is top heavy. And then this is the remainder that we need to figure out the partial fractions for. So how do we turn this into a mixed number? We do polynomial division. Okay? So polynomial division we're going to stick that in the box. So x squared plus 3x plus 2. And I don't know how many columns it's going to have. What's my first step? I have to put this in the first box. If the first box is 3x to the third, what goes above it? Yeah, so the bottom of the fraction goes on the left, and then the top of the fraction will be inside the box. So what number goes right here? 3x, because 3x times x squared is 3x squared. So 3x. Now, if I know that that's a 3x, I can fill this in. 9x squared. And I can fill this in. 6x. Now, I add a column because I'm not finished. This diagonal here has to add up to be negative 13x squared. I have 9. How many more do I need? I need 4x squared. Negative? Oh, I said negative. It's a positive 13. Sorry. All right. If that box is a 4x squared, what goes up here? 4 plus 4. And then 4 times 3x is 12x. And 4 times 2 is 8. Am I finished? No. I've taken care of this one. I've taken care of this one. I'm not finished, so I add a column. Okay. This box and this box and this box need to add to be 19x. How much do I already have? 18. How many more do I need? Just 1. And if this is an x, what goes on top? I can't do it. Why? I've run out of x's. I don't have enough x's. So anything else that occurs beyond this line, Carly, is a remainder. So x is a remainder, and then I need to create a 14. So what goes there? 6. So the answer is 3x plus 4 plus x plus 6 over what? X squared plus 3x plus 2. Okay. I have now converted my top-heavy fraction into a mixed number. So I ended up with 3x plus 4, and my remainder was x plus 6 over x squared plus 3x plus 2. Now what should I do? Other than giving up, you need to find the partial fractions of the remainder. So we need to partial fraction this. So that is x plus 1 and x plus 2. So A over x plus 1, B over x plus 2, and that is equal to x plus 6 over, like that. Okay. So this one needs an x plus 2, and this one needs an x plus 1. So when I distribute, ax plus 2a plus bx plus b equals x plus 6. Okay, I did that really fast. Does everybody follow? Everybody's good? Any questions? Okay. Now I filter out the two equations. a plus b equals 1, and 2a plus b equals 6. So I'm going to turn the top one into negatives, add vertically. Oh, that's an a, sorry. This should be an a. When I add vertically, I get a equals 5. And if a is 5, then b has to be, look here, a plus b equals 1. So b would need to be negative 4. So what's my answer? 3x plus 4, that's the whole number portion, plus 5 over x plus 1 plus, minus 4 over x plus 2. Let's check that and see what happens. Yep. They just wrote it backwards, but it shouldn't matter. Unless they tell you that it matters. Okay, number 6. Okay, so this is something that was not covered in the book, but it is pretty common in 1050. And it is non-linear systems. So what type of equation is this? Y to the first minus x to the first. What structure is that graphically? It's a line. Okay? Y to the first minus x squared. What is that? It's a parabola. So where could a line, how many times could a line and a parabola intersect? 2 times, or 1 time, or 0 times. Right? So you're just going to use substitution every time. Could we solve for y on the top? Yes. Could we solve for x on the top? No. Why not? We have an x squared and an x. So how do you get an x by itself if you have an x squared and an x? You can, but it's certainly not anything we want to do. Could we solve for y on the bottom? Yes. Could we solve for x on the bottom? Yes. So of those 3 choices, y on top, x on bottom, or y on bottom, which one do we want to do? I would choose y on bottom. How come? So let's look at both. So, okay, I'll show you another way here in a second. So I'm going to add this over. 3y equals 4x minus 4. And then divide by 3. And I get y equals 4x minus 4 over 3. Okay? Then I can stick this in here. And I get 4 times 4x minus 4 over 3 minus x squared plus 2x minus 3. Okay, I don't like fractions. Or sorry, equals. Negative 3. I don't like fractions, so what could I do to get rid of the fractions? Times everything by 3. But, what if I solved the other way? What if I said, so I'm going to subtract this over, negative 4x equals negative 3y minus 4, divide by negative 4, x would be 3y plus 4 over 4. Do I really want to plug that in here and in here? No, you could, it would work, but I wouldn't recommend it. Okay, let's solve for y on top. So y is equal to x squared minus 2x minus 3 over 4. It's actually not bad. So where would I put that? I would stick it right there. So 3 times x squared minus 2x minus 3 over 4 minus 4x equals negative 4. So it actually looks like the first method and this method are equally difficult. Okay? What about elimination? Could we use elimination? Could we eliminate the x's? No. I could eliminate the x, but not the x squared. Could I eliminate the y's? How would you do that? Times the top by 3 and the bottom by negative 4. That might be the easiest method. What's that? So the bottom by negative 2, how come? No, that would be negative 6y. Oh, sorry, you can't see that far. Okay, so any one of these methods will work. If you did this one, times everything by 4, that cancels that, and this would become a 16, and this would become a 16, and then you would multiply the 3 in. But I think elimination is the way I want to do it because I don't have any fractions. So the top, 12y minus 3x squared plus 6x minus 9 equals negative 9. And then the bottom would be negative 12y. And I'm gonna skip this gap here and then put 16x equals 16. Y's cancel. And I get negative 3x squared plus 22x. And then negative 9 and 16 make a 7. But the 7's on the other side. So I want to bring it over using subtraction. All right. I don't like this. What do I not like? I don't like the negative, and I don't like the 3. Can I get rid of the 3? No, it doesn't divide out. So I'm just going to change the signs. Okay. How do we factor a polynomial, a quadratic with a leading coefficient? You could use the quadratic formula. Yeah, that would work. I'm going to try this. 3x squared and 7. Multiply those together and I get 21x squared. Can I create a negative 22 using a 21? Yes, negative 1 and negative 21. So negative 1x, negative 21x, pull out an x, I get 3x minus 1, pull out a 3x. So 3x minus 1 equals 0, and x minus 7 equals 0. Okay, now, I think you can do everything up to here using one of those two methods, but there's one little step at the end we have to be careful with. So x is 7 and x is 1/3. Are we done? No. What are we looking for? I'm looking for the solutions to this nonlinear system. What have I just found? I found the two x values of the two solutions. So I need to plug those back into the equation to figure out what the y values are. So I'm going to plug them in here. So 3y minus 28 equals negative 4. So I add 28, that's a y. 3y equals 24. So y is 8. But that is attached to the 7. That is one solution point. Okay, and then I try 1/3. Not making this fun, are they? 3y minus 4 times 1/3 is 4/3. I'm just going to times everything by 3. Get rid of that. So 9y minus 4 equals negative 12. Add the 4. 9y equals negative 8. Divide by 9. Y is negative 8 over 9. So the other point is 1/3 comma negative 8 over 9. So my guess is that you need to do 7, 8, and then 1/3 negative 8, 8 ninths. Let's try it. Enter each solution as an ordered pair. So, yeah, why would they do that? Does anybody have this same problem? Somebody, can you try a new problem? Well, but so there are only so many questions. Will somebody see if they can find this exact equation? So maybe I think you have to submit and then go back in. Oh, I want my answers. So yeah, somebody see if you can get that same problem. Okay, so if I refresh, continue. All right, let's see if it works. Try again. Oh, wonderful. Okay. So, thank you, Kylie. 7, 8, comma, and then I want to do 1/3, comma. That's not a comma. That's a comma. That's comma negative 8 over 9. Oh, good. Okay, good. You can put it in as a decimal or fraction. I wouldn't do decimal because if it repeats, how do you know how many to put on there? So just keep it as a fraction. All right, that's good news. Okay. So here we have a parabola and a circle. So a parabola intersected by a circle. That's not a circle, but you get my drift. So this could have 4 solutions, or 3, or 2, or 1, or 0. Okay? Chances are it's going to have 4. Okay? It's actually not that bad. So, can we use substitution? Yes. I could stick this in there. And then I could do 3x squared plus 3 times 3x squared plus 3. Could I do elimination? You actually could if you lined it up right. So if I moved this over, negative 3x squared plus y plus 3, and then I put the x squared plus y squared equal, my goodness, I'm getting really good at that today. So I'm going to times the top by 3, 3, and 90 plus 21 is 111. Somebody check that. Is it 111? Okay. So if you did substitution, you would get x squared plus 3x squared plus 3 squared. I don't like that. That's going to create an x to the 4th. Right? I would get x squared plus 9x to the 4th plus 3 times 3 is 9, double that, 18x squared plus 9. So 9x squared plus 19x, or that's a 4th, x squared plus 9. And then you'd have to factor that. Actually, I'm going to do both. Yeah, I definitely want to show you both. Okay, so on the left side, x's cancel. 4y equals 114. Oh, tell me I messed up somewhere. Oh, it's y squared. Oh, thank you. Thank you. Okay, so those don't add together. 3y squared plus y equals 114. That makes me much more happy. Okay, so 3y squared plus y minus 114. So we need to factor that. Does somebody have a factoring thing on your calculator? No? Okay. For the sake of time,